In today's lesson, we're going to go from talking about unit cubes to talking about formulas for finding volume of different three-dimensional shapes. All right, we're going to start today with looking at a rectangular prism. And so I have an example of one here, and we're going to use this to kind of visualize a little bit of what the question is asking us so that we can kind of see what it's talking about. A couple vocabulary terms I would like to go over with you. We don't necessarily need these in our ISN unless they're ones that are new to you or ones that you have forgotten. But just kind of a review of what you've talked about in the past. The first one that I want to make sure that we remember is face. The face of a three-dimensional figure, remember, is the flat part on each side. Okay, this is a face. Each of these rectangles along here is a face. They're all faces. Okay, so we're going to really definitely need to know that one today because we're going to be talking about the face. Also, we have the edges, which is the line. I'm going to point with a pen here, it'll be quicker, or smaller. The line that is created by the two faces, where they come together, kind of like the corner edge there, is the edge. And then the point where all those edges come together is the vertex, or multiple vertexes we call vertices. Okay, so that's just kind of a review of some of those terms that you probably already know, but we kind of just want to make sure before we get talking about them and then you're a little bit confused. Okay, let's go ahead and move to our first example. Example 1, we're going to look at these three rectangular prisms. So it's this shape, just a picture of it. Okay, so we have 15 inches by 1.5 inches this direction by 3 inches tall. Okay, and this is the same thing, the same shape. It's 15 by 1.5 inches by 6 inches tall. This one is 15 inches by 1.5 by 9 inches tall. As you can see, this is just a model, it's not really the shape. Okay, so what we want to do is we want to first write a numerical expression for each one, meaning what would we plug in for our volume? I'm going to put our volume formula back up here that we know. Length times width times height. Okay, so let's start by writing the numerical expression for the first one. I'm going to focus here so we can read those numbers better. Okay, so we have the length of 15 times the width of 1.5 times the height of 3. Okay, we don't need to solve it, it just asks for a numerical expression, so that's all we'll do. Let's do the same thing here. So we have length times width times height. Okay, and then the same thing for this one, length times width times height. Okay, now looking at all of these, my question is, what do they all have in common? Well, I notice that they all have this first part in common, the length times the width. Now, what does that number represent, the length times the width? Well, if I look at this three-dimensional shape here, let me make it a little bit closer for you. If I look at this three-dimensional shape, the length is here, the width is here. Now, that's the area of one of the faces, length times width. Or length times, or base times height, length times width. That's going to give us the area of one of our bases, one of our faces. Now, if it's sitting on that face, which it looks like in here, it's sitting on that base down here on the bottom. If it sits on that face, we call that the base of the three-dimensional shape. So that's the base that it's sitting on. So this is the area, this part right here is the area of the base. So we're finding the area of the base of this one, and the base of this one is the same, it's just taller, but the base is still the same area, so this is the area of the base, and this is also the area of the base. The base is what it sits on, okay? So this base On the bottom is what it sits on, and we find the area by doing the length times the width. Okay, now, based on that, let's write a new numerical expression to figure out to show a little bit better what they have in common. So I'm going to use my calculator. And I know a half is 0.5, so I'm going to do 15 times 1 and a half. And I'm going to get 22 and a half, but I'm going to put it back in a fraction. Okay, so this is 22 and a half times 3, because that's the 15 times 1 and a half became the 22 and a half. Bring down the 3. This one then would be the same, 22 and a half, but it's times 6 because it's a taller shape. And this one is 22 and a half times 9. Now we can see that they are all similar. They all have that in common. Okay, so we know that our formula for volume is length times width times height. If we found that length times width is really the area of the base of the three-dimensional shape, then our new formula, we have a new formula that we can use to come up with the area of a three-dimensional shape, or the volume of a three-dimensional shape. That new formula is volume equals area of the base, and that is written as a capital B, because area, we know, is written as a capital A. This is the area of the base times height. And we don't read it as base times height, we read it as area of the base times height. All right. What is the area of the base? Well, the area of the base is 22 and a half. So we're going to find the area, or the volume, we're going to find the volume of each one of these. And we can use either formula. We could use this formula or this formula, and it should give us the same answer. Okay, let's try it. I'm going to try the first one with this one. Okay, so I'm going to take 15 times 1 and a half times 3. 15 times 1 and a half is 22 and a half, so I'm kind of down here at this, right? So 22 and a half times 3. So I'm going to go ahead and use my calculator. It still says 22 and a half. I'm going to multiply times 3. And I get 67 and 1/2. And it's inches. Because it's volume, it's cubed, because we could fill it with cubes. Okay, I'm going to put a box around this now, because that's our volume. The center one, we had 22 and a half. Oops, 22 and a half times 6. We have 135. 135 inches cubed. Okay, let's do the last one here. Kind of scoot this over so we can see it. We have 22 and a half times 9. 202 and a half. 202 and a half inches cubed. All right, now what is the relationship? What is the relationship of each of these numbers compared to the first one? Compare this one to this one. If I compare those two numbers, I notice if I compare these two numbers, the 3 and the 6, this one's 2 times bigger than this one. Let's see if the volume is the same. Let's do 67.5 times 2. Oh, it works. So this volume is twice that one because it's 2 times as high, 2 times as tall. See, this one's 3 inches tall and this one's 6. Based on that, if I look at this one, it's 3 inches and this is 9 inches, then this one should be 3 times as big as this one because it's 3 times higher. Let's see. Take 67.5 times 3. And we get 22.5. Interesting. All right. Now that we know our new formula, area of the base times height, I'm going to put that up here. We could also use area of the base times the height. Sometimes we'll give all 3 dimensions and we can find it. Sometimes we only know the area of the base, the face on the bottom, and then we have to multiply that times height. Okay, let's look at example 2 at the bottom. Zoom in a little bit, kind of looks far away. There we go. Okay. The base of a rectangular prism, okay, so that's the bottom, so we know the area of the base, has an area of 3 1/4 inches squared, and it's squared because it's an area. The height of the prism is 2.5 inches, so it's 2.5 inches tall. Determine the volume of the rectangular prism. So we're going to use this formula here because we know the area of, oops, sorry, you can't see it. Because we know the area of the base, we're going to use this formula, okay? We know the area of the base. We don't know the dimensions for it, but we know its area. So we're going to plug in the area of the base is 3 1/4 times the height of 2 1/2. Okay, let's go ahead and multiply these. 3 times 4, we're going to change first to a mixed number. So 3 times 4 is 12, plus 1 is 13. 2 times 2 is 4. 4 plus 1 is 5 halves. Okay, I'm going to multiply 13 times 5. I could do it in my head, but I want to write it out. Make sure. 3 times 5 is 15. 5 times 1 is 5, plus 1 is 6. So I have 65 over 8. Now I want to make that into a mixed number because that's just easier for my brain to wrap around. So I'm going to take 65 divided by 8. I can do that one in my head, but I will write it out too so that we can see both. 65 divided by 8. I know 8 times 8 is 64, so that is very close. So I have 8 whole. And I'm left with 1, so I'm left with 1/8. Here's how I did it. For those of us whose brains aren't ready for that, that's okay. I can do it 8 times, which is 64. I have left over with 1/8. Okay, either way, we get there about the same speed, so either way works great. And that is inches, it's volume, so it's cubed. 8 1/8 inch cubed. All right, that's it for our lesson today. If you have any questions, you know the drill.